All right, welcome back, everybody. Today we are going to be talking about standard GQ5, which is parabola transformations. Now, this topic is going to vary a little bit from what we've been previously talking about. Previously, we've been talking about functions that were all of the form y is equal to ax squared plus bx plus c. Today, we're going to be specifically focusing on functions that don't have this bx part. So this bx part is going to be gone, and we'll strictly be left with something that looks more like this. Y is equal to ax squared plus c. Now, when we are in this form, we can look at the numbers that are part of the problem, and we can actually predict what they're going to do to each of our graphs. They're going to kind of transform it. Now, right off the bat, we have what we call our parabola parent function. Y is equal to x squared. This is what all of the functions in this mode kind of look like in their most basic form. Now, notice in this problem, y is equal to x squared plus 0 would be equivalent to it, right? Because adding 0 doesn't actually change what we have going on. So this is our normal parent function, and what we're going to be doing today is we're going to change it. We're going to change it a couple of different ways. We're going to be able to make it skinnier or fatter or narrower, if however you want to look at it. We're going to be able to vertically move it up or down, and then we are going to be able to actually kind of flip it, just depending on different numbers that are applied to it. So looking over here, we have a couple different things. What we notice about this one, right? So if we just try to go back as close to that original form as possible, that ax squared plus c, we could put a 1 right here and a 0 right here. Now, remember, the 0 kind of is part of this. We just don't necessarily need to show it every time if it's not there. So we do have plus 0 in here. So we are thinking we're kind of similar to that. But one thing you need to know here is that if the number in front here, if this number is negative, then what that is going to do is that's going to flip your graph upside down, and we are now going to be concave down, right? So if we have a negative in front, that's going to make our graph concave down. Now let's take a second and talk about what the C value does, because in this one I can see that the C value is the only thing that's changed, and now it's a positive 3. So when I have a C value that is that positive 3, what that is going to do to my graph is that's actually going to shift my graph up. So what this number does right here is this number is going to move our graph up or down depending on if it's plus 3 or minus 3 or any other number. If it's plus 3, then what you're going to see happen to your graph over here is that your graph is going to move up 3 units, kind of like we see right there. Right? Versus where like the concave down one, if it's just that negative 1 in front, that's just going to flip your graph, and now it's going to be opening up like this. Let's actually try to color code these a little bit. So this will be my blue one, and then I'm going to make this one my purple one over here. So I'm going to, let's see if I can do this. Style, let's make it purple. And that one was our concave down example, so this was that one. So if I just do that, that will make this purple. So, boom. All right, let's go to the next one. So looking at the next one here, we'll do this in this goldish color. We have y is equal to 3x squared. And what this is going to do is this is actually going to make our graph taller or narrower. So the way that this one works is if there is a number in front of that ax squared, again, if it's a negative number, it's going to be that flip. But if it's any other number, if that number is bigger than 1, then it is going to make our graph taller or narrower. So this is going to be what we call it a vertical stretch. And the way I like to think about this one is like Play-Doh, right? If I had a chunk of Play-Doh in my hand and I sat there and I started to stretch it, it's going to get taller, but at the same time it gets taller, it also gets skinnier, right? So that's a vertical stretch, and that's going to happen anytime that we have a number in front of there that is bigger than 1. Now, over here, we can see that we have a number in front, and that number is smaller than 1. Whenever this number is less than 1, or almost I should say between 0 and 1, let's go back and say that. So between 0 and 1, then our graph is going to get shorter and wider. We call this a vertical compression. And you can think about this like Play-Doh too, right? If you had a ball of Play-Doh in your hand and you pushed it together, it's going to kind of ooze out the side. It's going to get shorter and wider at the same time, right? So these are all of our different transformations. Let's try to actually graph the gold and the green one. So the gold and the green, if this is just a 3, then our graph's just going to get taller and skinnier, right? So we see it get narrower. If it's going to get shorter and wider, then it would look something more along the lines. It's going to kind of come out more like this. Now, of course, there's a mathematical way to adjust those to make sure we're hitting all the points necessary, but today we're just really focused on looking and identifying those transformations. So, just like always, I'll do the odds and we're going to save the evens for you. So, looking over here at problem number 1, first thing we want to know is it concave up or concave down? And in this one, our answer is going to be relatively easy. It's going to be concave up. And the reason it is up is because there is a positive 1 here, right? So let's give a reasoning here. A is positive, right? Remember, that's our biggest indicator as to if we are going to be concave up or concave down. Now, this one asked, are we wider, narrower, or neither? So remember, the wider, narrower, or neither, that comes from the idea of these two pieces. And it really refers to that A piece again. If A is equal to 1, that's our situation where it hasn't changed. So we're going to say neither. Remember, both of these either rely on being bigger than 1 or between 0 and 1, so smaller than 1. The last part is, are we shifted up or down or neither? And we can answer that relatively quickly. Looking at this back piece, this is the piece that moves our graph up or down. Since it says -4, that's going to move our graph downwards. Nice job. Let's go to the next one. So here's our next one. So let's put a +0 on there if we don't see it. Fill in those missing pieces. Looking at this graph, we can see that we have a negative out front. That negative means that our graph is going to be concave down. Now, in terms of is our graph going to be wider, narrower, or neither? The way I like to think about this one is I like to look at the number that's sitting right here. Now, notice how I didn't put the negative in there. We've kind of taken care of the negative by identifying that our graph will be concave down. So since I have that 5 in there, 5 is bigger than 1, right? So 5 is bigger than 1, which means if you come back up here, if we are bigger than 1, I went through my 1, that's going to be a vertical stretch, and it's going to make our graph taller or narrower. Those two ideas, they're two different words, but they mean the same thing in this situation. So narrower is the option that works for us because that 5 is bigger than 1. The last part says, is our graph shifted up, down, or neither? And this one is identified by this last piece. Since that's a +0, that means we didn't move. We didn't move up, we didn't move down, so that means neither would be the appropriate response. Let's look at the next page. Looking at problem number 5. Again, to determine if it is concave up, you just want to check on the number that's in front of x squared and say, is it positive or negative? That one's positive, so we will be concave up. Looking at the next part, it does ask us, is it wider, narrower, or neither? Again, that refers to this number right here. Is that number bigger than 1? Of course, 9 is bigger than 1. So when that happens, it's a vertical stretch, meaning it will get taller. And if you were to sit there and stretch out Play-Doh, the taller it gets, the narrower it also gets too. Taller and narrower go together. Shorter and wider go together. Last part here says, is our graph shifted up, down, or neither? That's where you look at this last piece over here. Since we are adding 8, we added 8, that is going to refer to shifting us up. If you subtracted 8, we would have went down. Here's another one right here. Again, we say, are we concave up or concave down? Well, I see a negative in front here, which means we are going to be concave down. Looking at our number right here, 1/2 is less than 1. So that means this will be a vertical compression as per our definition earlier. If we vertically compress, that's when we take the Play-Doh and we push it together, it's going to get shorter and it's going to come out the sides and get wider. Wonderful. Now let's talk about our vertical shift. So coming over here, we do see that we are adding 2 at the very end. Whenever we add, we move our graph up. I think this is our last one right here. So is this graph concave up or concave down? Well, this number right here is a decimal. Sure, we haven't really seen that yet, but it's positive. And since it's positive, it means we are going to be concave up. 1.25 is greater than 1. As long as you're bigger than 1, then it's going to be that vertical stretch. Think about it. If you took Play-Doh, you stretched it out, it's going to get taller. And at the same time it gets taller, the sides kind of compress in and it gets narrower. Last part says, are we shifted up, down, or neither? Well, over here we added 32, which means we are moving our graph up. Just like that, guys, we are done with the odd problems. Again, your homework today is going to be the even problems. So 2, 4, 6, 8, and 10. Thank you guys so much for watching. Remember, if you have any questions, just make sure you're reaching out and asking. Thanks, guys. Have a good day.